So that's it for me. Thank you very much. And so I will turn it over to Aisha as today's host to introduce our presenters and moderate our session.
Great. Thanks, Megan. My name is Aisha Massel. I work at Sustainable Conservation in our water program, and really appreciative of everyone who's been able to join today. I'm really happy to introduce this LunchMAR topic since it is a main area of interest for us at Sustainable Conservation. As major proponents of FloodMAR, we want to make sure that groundwater recharge is done correctly and without negative impacts to people or the environment. And so one of these considerations is making sure that water diverted off of streams and rivers for the purposes of recharge does not lead to harm to riparian and aquatic ecosystems. So the California Environmental Flows Framework, otherwise known as CEFF, is a promising way of holistically managing freshwater systems throughout the state. It could also potentially help FloodMAR proponents to understand the ecological needs of rivers so that we could harness excess water for recharge without harm to the environment. And so it is my pleasure to introduce two presenters, both of whom have been involved in developing CEFF since its inception. Our first presenter, Sarah Yarnell, is an associate professional researcher at the Center for Watershed Studies at UC Davis. Her research applies understanding of river ecosystem processes to manage systems throughout California, with a focus on the improvement and maintenance of riverine habitat through environmental flows and process-based restoration. Our second presenter, Bronwen Stanford, is the lead river scientist for the Nature Conservancy's California Water Program. She provides science leadership and technical expertise for a variety of projects, including statewide tools and data sets that seek to improve river flows and water management for freshwater biodiversity throughout California. And just to reiterate a final note to our participants, during the first presentation, you can type in the chat any clarifying questions and we can answer them during the break or in the chat itself. And then please hold off on any substantive questions until after Bronwen's presentation. And so without further ado, Sarah, please take it away.
Thanks so much. It's a pleasure to be here with you all today and to be able to co-present with Bronwen and the other CEFF technical team members that are here. Just to give you an overview, so I'm going to begin by talking briefly about functional flows, the functional flows approach, which is a type of environmental flow, holistic environmental flow approach we could take to understanding and trying to come up with ecologically supportive in-stream flows in our rivers, and give you a brief introduction to CEFF, the California Environmental Flows Framework. And then Bronwen will take that short break. And then Bronwen will pick up and talk a little bit more about the integration between CEFF and FloodMAR, and hopefully then lead into some nice discussion and questions from the audience. So next slide, please. So when we discuss environmental flows in California, so this is the amount of water that should be left, or we think we would like to leave in rivers for ecological purposes, the question often gets asked, how much water should be left? And we tend to, there's a whole variety of ways out there to look at environmental flows or think about how to determine environmental flows in a river. And the answers, though, typically tend to focus on an annual volume or a set minimum in-stream flow or a particular CFS at a certain type of year. But here in California, where we have a very seasonal climate, we have wet, cold winters, we have warm, dry summers, the pattern and the timing of when water is in the river and how much water at what times is really critically important to the ecological systems and the way that the system has evolved in California. So I really like this diagram as a way to kind of highlight the importance of that seasonal variability, and in particular, the multiple benefits that we get in our ecosystems from the floods that happen during the wintertime. So in the hydrographs at the top up there, you can see that the volume under the curve is actually the same annual volume, but it's being released in a very different pattern. The one on the left is a more natural flow pattern, like what we would see in our unimpaired rivers. And you can see that during the wet season, when we're getting a lot of rain, our river flows increase, and that's the time when we tend to get natural high flows and natural floods that flood out of the channel. They connect with the floodplain. They really do a lot of work in terms of scouring and eroding and creating habitat and providing additional space for fish and other aquatic species to do their reproduction, to spawn, to migrate, to move, to take advantage of all of the wonderful food production that happens out on the floodplain. And then during the low flow season, those flows are receding, and you sort of are left with this diversity of habitat. And our native species in California are really evolved. Their entire life history is evolved to this annual, seasonal pattern that happens every year in some degree. When we alter the natural flow regime or those natural patterns of flows with dams, you can end up with a really different type of flow release schedule where you might actually end up with low flows through most of the year. So you're losing, in a lot of ways, the multiple benefits that we get from floods, where the water gets out, you're creating more habitat, you're recharging the groundwater next to the stream. Really, a lot of that functionality can be lost when we alter the flow regime and really limit access to the floodplain. And so thinking about floods as all the benefits that they can provide can help us as we move forward, thinking about how to relate with managed aquifer recharge for floods as well. Thanks. Next slide. So one approach that we have in terms of determining how much water should we leave in the system at what time is to really think more holistically about this pattern of flow over space and time. And one approach that we've been working on and advocating for throughout California that we think is very applicable to California and our seasonal climate is this idea of a functional flows approach. So this is a type of determination for environmental flows that is really focusing on what aspects of the flow regime are most important for that ecosystem functioning. And we want to, really highlight and perhaps preserve or reintroduce into our regulated systems these functions that we know really drive ecosystem diversity and help to support and maintain our species. So if you look at the two graphs over here on the right, the top one illustrates the different types of abiotic or physical functions that we might get at differing flows. So as flows get higher, you're not only wetting gravel bars, but then you're, ultimately getting gravel and sediment to move with higher flows. So the gravel becomes mobile, pools flush, you get redeposition of new bars, the sediments are cleaned out, which creates great spawning habitat for fish in the river. And at the highest flows, at those flood flows, you're getting flows that go out onto the floodplain. They're recreating that habitat. They're sitting out there over an extended duration out on the floodplain. That water soaks in, it's recharging the groundwater, it's saturating the riparian zones that are out there and gradually receding back in. So there's a lot of physical and sort of abiotic functions that we can think about that happen with high versus low flows. But similarly, the timing of when those high flows come down are really important for our native aquatic species. So this lower graph sort of shows the timing of when we would naturally have, for example, steelhead or salmon coming into spawn and when they might be out migrating. Cottonwood and willow release their seeds in the springtime in conjunction with those naturally receding flows where we transition from the wet season to the dry season. And so because all of these aquatic and riparian species have evolved with this seasonal pattern, it's important that when we're trying to preserve the flows that are going to be suitable for these species, that we think about the timing of when those flows come down as well. So we can think about these functions that are really out there driving the ecosystem and the native species that we want to preserve in our systems and consider developing environmental flows that support these functions. And it's important too to think not just about flow in time, but also flow in space. And can we achieve the functionality? If we want to have a floodplain flow and we want to get high flows spilling out on our floodplains, well, then we need access to the floodplains, right, to get out there. So it's a consideration of flow in time and space that we're trying to achieve with this functional flows approach. Okay, next slide. So what might this look like? So we can define a functional flow then as any piece or component of the hydrograph that provides a distinct function, but we really want to emphasize that it needs to be reflective of those natural patterns. And so on this graph here, you can see there are 5 distinct components that we might call out from our natural flow regime. The natural flow regime being that blue line there that's representative of a Sierran river system where you get rain events that come down at the mid elevations in early winter, and then a snowmelt recession that comes down in spring down to dry season base flows. And so we might retain aspects of these particular components that we know are ecologically and geomorphically really important and allow for withdrawals and consumptive uses to be happening during the wet season when we do have an abundance of water. And so a functional flow regime might, for example, look like this red type of hydrograph that we have here. This is one of many examples. Okay, next slide. So I'd like to just briefly talk through some of the distinct functions that happen and why we chose to retain these 5 functional flow components within a functional flows approach. And again, the idea is that we're after a holistic picture of not just trying to maintain 1 or 2 functions or 1 or 2 components, but if we really want to preserve the full functionality of an ecosystem or riparian ecosystem, we need to keep all 5 in. So the fall pulse flow, it's that first flow of the year that comes down. We've had this long dry season. We're now entering into the wet season. And these first flows are really important in that they're sort of fleshing the bed, clearing the bed of organics, re-engaging the hypereic zone and that adjacent channel riparian dynamic. These are often also the migratory cues for a lot of the cell-mounted species that migrate into. These flows provide the cue to migrate upstream at the beginning of the wet season when water is starting to come back into the system and the habitat is opening up again, essentially, for them. And so this is an important flow component that we'd want to keep in a functional flow regime. Next slide, please. And these peak flows, these flood flows, also do serve ecological purposes if we have space where they can get out onto the floodplain. So if we think about structuring the river, maintaining habitat, scouring and depositing sediment that's so important to providing the different types of habitats that our native species need, this is happening during our flood flows, right? And they're most effective when we're giving them space, right? You don't want to just fill up a canal with a bunch of water. Is that really providing the functionality that you need? But rather, we want to have these large floods that can go through, connect with the floodplain, and really do the geomorphic work that we know that's really important to maintain these river systems over time. And we might, particularly if you look at that graph at the upper top part, we might not need every flood to come down the river necessarily. If we're going to have to give up water for consumptive uses, we know we're not going to be able to have a full natural flow regime that comes down, but it's important to keep at least some floods at close to full magnitude so you can actually get the functionality of that flood. So rather than 2 half floods, we might promote 1 full flood to really get the functionality that we would want. And this doesn't necessarily happen every year, but should be happening every couple of years, right? During our wet years. Okay, next slide, please. The wet season base flow is an important connectivity aspect. We do have higher flows in the winter than we do in the summer. And so our base flow regimes in our regulated rivers should really reflect that. There's a lot of the cell-mounted species that reside over the winter. They're doing their spawning over the winter. We need to be able to move. They need to be able to move around the network. And so having slightly higher base flows in the wet season versus the dry season is important to maintain that connectivity upstream to downstream and throughout the river network. Next slide, please. The spring recession flow is an important one, particularly for ecological cues. So this is the transition from this large wet season that we've had through the winter down into the low flow of the dry season. It's very predictable. So in a lot of our larger rivers, the snowmelt, it doesn't happen overnight. It happens gradually. And so you get this gradual decrease that usually extends over several months from high flows to low flows. So it's a very predictable signature in our annual flow regimes that almost all of our native species have evolved and adapted to taking advantage of. So salmon are out migrating out of the system on the spring recession. Foothill-legged frogs are timing their reproduction in the river at the tail of the recession as the flows gradually decrease into the summer. Cottonwood, their seeds are being dispersed during May and June so that they can go out into the water, settle out gradually on the bars, and as those flows gradually recede, they're germinating and their roots are growing and following that gradual recession down into the low flow. So a lot of our native species have evolved to this gradual decrease down into the dry season. And so this is also a component that we would want to maintain in a functional flow regime within our native systems if we want to support these native species. Okay, next slide, please. And then lastly, the dry season low flow actually can be a pretty important indicator, particularly in some of our seasonal river systems where, the diversity of the system is really high because a lot of the riparian plants and aquatic species there have evolved to deal with these low flows. And a lot of our native species have also evolved to deal with these low flows. Most salmon outmigrate out of the system before the flows get too low. A lot of the native species that stay within the system have evolved to adapt by hunkering down in the hypereic zone, migrating upstream. And so if you are providing the other flow components during the year. You're providing higher spring flows, you're providing flood flows. Most of our native species are actually adapted to deal with these low dry season base flows that naturally occur. And so having a little bit of variation between the wet season base flow and the dry season base flow is something that our species are adapted to, and something that we can put into our systems in the way that we design environmental flow regimes or functional flow regimes throughout California. So next slide, please. So we would work to retain these key components or aspects of these key components within a functional flow or a functional environmental flow regime. But we also want to be cognizant of varying that within dry years to wet years. So rather than just a single hydrograph that you might, flow schedule that you might release in all years, we would, if it's a wetter year, we want to be able to provide more water, as would naturally happen in a river system. Whereas in dry years, you might have smaller pulses. The spring recession might be a little bit earlier, a little bit shorter. And that variability over time is just adding to the biodiversity that sustains our aquatic ecosystems. So when we think about functional flows, we're thinking about maintaining key aspects of the flow regime, and we're thinking about varying them over interannual variability so that they scale with wet years and dry years to sort of provide a natural overall flow variability that supports diversity within our aquatic ecosystems. Okay, next slide, please. So when we think about functional flows in California, we're really focusing on these 5 key components: dry season base flow, wet season base flow, the fall pulse flow, the spring recession flow, and these peak magnitude flows. And we can quantify these flows with a series of metrics that describe what is the magnitude of these flows, what is the timing and the duration. And we can really guide our design of functional flow regimes using the numbers around these components. So next slide, please. So we have metrics, which I'll show in the next slide, that really quantify these functional flow components. And what CEFF is, or the California Environmental Flows Framework is a guidance document and framework that helps provide pretty much anybody in the community, all of the stakeholders who'd be interested in environmental flows within a watershed, with a similar framework that has a series of steps to implement a functional flows approach. So again, the idea of CEFF is a guidance framework and a methodology to implement a functional flows approach, but in a consistent, transparent, open, and a flexible way. And so the website where you can get all of the additional, really dive into the details of all of this, is ceff.ucdavis.edu. And we don't have time in this talk to really go into the details of how exactly the framework is set up, but there's different sections, which we'll show in the next slide or two, and I'm just going to give a brief overview of it here. But again, the idea is this is a framework on how to go about implementing a functional flows approach for any stream in California. Okay, next slide, please. And so here is the sort of overview of the framework. We break the guidance and framework down into 3 key sections: section A, B, and C. The first section really focuses on just identifying ecological flow criteria. So what are those quantifiable metrics and those 5 functional flow components for my river of interest that I know my native species have evolved to? There's a section B, which allows you to dive a little bit more deeply into whether or not those components are going to be functional within your particular river system, allow for some site-specific studies to come in. But these 2 sections together, section A and B, are very science-based. And we've designed and sort of organized the framework in this way to really be very explicit and clear about the science behind the ecological flow regime. What are the ecological needs of the system? And then in section C, really doing this trade-off analysis between what are the ecological flow needs with the non-ecological flow needs. What do I need for management? What do I need for water use? What do I need for agriculture? And sort of placing those socio-political considerations into an adaptive management framework that allows for discussion and monitoring and iteration. So we've designed the framework in this way to be very flexible, to be very transparent and clear about what is the science, what are the trade-off considerations, how should we go about, and determining and really coming up with final environmental flow recommendations for a particular river. And so in this framework, there's the space and the flexibility for considerations like sigma or groundwater connection, or FloodMAR and floodplain recharge, and how to account for those and analyze these within the context of the larger sort of management of the river system, and considering ecological needs within all of that together. Okay, next slide, please. And so just as I want to just come back briefly to this idea of the functional flow metrics, because this will be part of leading into Bronwen's discussion in terms of how this could relate to FloodMAR as well. But each of these 5 components, we have a series of metrics: magnitude, timing, duration, rate of change, that are numbers we can put on these flow components. And in particular, for the peak flow magnitudes or the flood flows, we focus on the 2-year, the 5-year, and the 10-year recurrence interval flood as being ecologically important. So although we know we're not going to be able to potentially maintain all floods and all winter high flows in the system if we're going to abstract some water for human uses, we focus on maintaining the recurrence and value of a 2-year flood because it does such a good amount of work in terms of re-wetting the riparian area. The 5-year flood has shown to be very important for that floodplain succession and cottonwood recruitment. And the 10-year flood being sort of that value that, you know, once a decade or so really can get out and reshape our riparian zones and our floodplain systems. And then maintaining some aspect of those 3 types of flood flows within our systems is what we sort of are advocating for an ecological perspective. So this does not imply that every single flood needs to be retained, but that some aspect of these larger floods that we know to be ecologically important might need to be retained. And so these numbers can be quantified within any stream in the state. And if we go to the next site, one of the tools we've developed for CEFF is on the Natural Flows web tool. This is the Natural Flows database that's maintained by TNC. And this is rivers.codefornature.org and is the website. And what you can see here is you can basically go in here, click on any stream reach in the state, and you will actually get the range of functional flow metrics along with the monthly natural flow estimates for every reach in the state. So it provides that information out there for everybody to be able to start in on Section A and start to go through this process of moving through CEFF if that's desired. So I'm going to stop there, and that's just the briefest of introductions, but I'm happy to take any clarifying questions right now before we move on to Bronwen's section.
Any questions in the chat? So in the interest of time, just going to move straight on to Bronwen's presentation. Thanks.
Okay, great. Yeah, so I'm Bronwen Stanford. I'm going to be walking through an example that builds on the information that Sarah shared in the first half. So this is sort of a brief summary of some of the concepts that she touched on in the first half. We can use functional flows to think about some of the ecological impacts of managed aquifer recharge and diverting some of the water that would otherwise have been in stream to other uses. So it could have impacts on the wet season base flow, on the peak flows, on the spring recession flows, and all of their sort of connectivity and queuing functions that those flows can provide. I also wanted to note that a reason we're really excited about FloodMAR and its potential is the potential to restore some of the dry season base flows that have been impacted in a lot of our systems based on the many different ways that we use our landscapes and water. So functional flows can help us both think about the potential risks of diverting water for recharge and also some of those potential benefits. So I'm going to spend the bulk of my part of this presentation just walking through an example to help us think about the tools that CEFF could bring to help us evaluate the ecological impacts of diversion and how different types of diversion schedules would look through this functional flows lens. So here's another example hydrograph. This is showing 3 different years, 2 that are pretty wet, 1 that is quite dry. This is a hydrograph that you might find in a lot of the coastal streams in California, where there's a lot of storms in the wet season and pretty low base flows in the summer. And we can overlay these hydrographs with some of the functions that Sarah walked through in her portion of the talk. So these are some of those abiotic or geomorphic functions that these higher flows are providing. At sort of slightly elevated flows, we might be wetting gravel bars. As flows increase, pools are flushing, gravels become mobile within the channel. And then at those highest flows, you might be resetting the floodplain, scouring and reshaping the channel. And CEFF, as Sarah mentioned, really emphasizes that maintaining the full range of flooding and this variability in the types and magnitudes of floods are really important. The 5 and 10-year floods were the 2 metrics that were chosen within CEFF to represent these higher floods. We also have a metric for a 2-year flood as a way of sort of representing these the higher flow level functions. Obviously, floods can keep going much beyond that level, but this is sort of a quick way of representing that flood variability that we want to be able to see in our rivers over time. So if we go back to this hydrograph, we can think about the different ways that diversions might be done. So first, we could consider a single threshold flow, which would allow water above that threshold to be diverted. This may be similar to a single species biological opinion or a relatively low bypass flow that might be in place on a lot of our rivers. And if we imagine that we have the capacity to take all of that water, I know in a lot of cases we might not physically be able to take all of that water, but if we say that's our environmental standard, what would happen to the environment if we hold that as our standard? We can think about what implications might be. So in this example, the threshold flow is relatively low, and the green line represents what in-stream flows could look like if all of the water above that threshold was diverted. So in this case, most of the wet season functions are performed by flows above that threshold. So we're not really seeing most of those functions. We're not even really getting out to the point of wetting gravel bars. We're certainly not doing those bigger channel reshaping functions. And another point to think about is that in this example, all 3 of the years look pretty similar under that diversion schedule. We take what was a wet year, a pretty dry year, and they all start to look pretty similar because those higher flows have all been removed. Obviously, this is a pretty low threshold in a somewhat extreme example. But we can also think about other types of rule sets we might use to manage diversion. So we can consider the 90th percentile 20% rule, which is the streamlined pathway developed by the State Water Board. This rule specifies that flows are available for diversion when they are at or above the 90th percentile of all flows for that calendar day, and that maximum diversions are allowable up to 20% of instantaneous flow. I'm sure a lot of this group is pretty familiar with this rule. If that's really confusing, we can definitely talk more about it. But it's sort of a way of identifying the highest flows and allowing those ones to be diverted. So the remaining in-stream flow under a 90-20 rule is shown here in the orange line, and you can contrast it with the blue line, which is sort of the natural hydrograph we started with, and the green line, which is that low threshold flow. And you can see that in this example, in contrast to that threshold flow with the 90-20 rule, you are hitting all of those key abiotic geomorphic functions at least some of the time. Another way to think about this is we can imagine in some of our rivers, we may already be operating at that green line. If there's a lot of diversions, if there's a major dam, we could be stuck in that green line position, and we could use LunchMAR and the ability to reintroduce some flooding and more flow variability into systems to maybe move further up and maybe recapture some of these functions that have been lost. And then to tie it back to CEFF more broadly, we can also directly use the CEFF functional flow metrics and ranges to evaluate these 2 diversion schedules and think about whether they're likely to be ecologically protective. So if we step through the different 5 different functions that Sarah talked through, so the fall pulse, actually even the threshold approach is protecting the fall pulse because it was pretty low. The wet season base flow looks pretty different for the threshold versus the natural or the 90-20. That function would probably be altered under the threshold approach, but looks good. Looks like we're achieving those functions under the 90-20 rule. We're still getting a lot of peak flows under the 90-20 rule. So that orange line is extending into the peak flows boxes. And then the spring recession magnitude is a little bit lower, but we're still getting a good spring recession. And then the dry season base flow is unaltered in all of the examples. And there's even a potential, as we were discussing earlier, that effective recharge could result in restored dry season base flow that is maybe moving back towards a place that's more in alignment with the functional flow ranges in cases where it's currently altered. CEFF, again, just to reiterate, really highlights the importance of considering functional flows year-round. However, as we were touching on earlier, this 90-20 rule does allow some of the highest peaks to be removed or reduced in frequency. So as you can see here, this highest peak in the first year is lower in magnitude. It still counts as a 10-year flood. It's still above this dashed green line, but it's lower. And then these high peak flows in the third year which were above this dashed line, are now falling below it. So the orange isn't quite getting above the green dashed line. A true CEFF schedule would protect the 10-year floods and allow them to pass through. So CEFF can be used as a check that flood functions are protected, especially over time. And it might specify that the first and highest floods of the season should be bypassed entirely to protect function, and maybe allow capture of some of subsequent floods for recharge or other uses. It also might say that we don't need a 10-year flood in the first year and the third year. So maybe it's okay if we're just protecting that 5-year flood function in that second group of years, as long as we're hitting the 10-year flood frequently enough to maintain the channel and perform those important functions. And a thing we really wanted to highlight is that, sort of in contrast to the percent of flow approaches, CEFF focuses on these key functional elements of the hydrograph, and it can be used to check that the functions are being protected by whatever sort of a diversion schedule you might be considering in a river. The last major point that we wanted to highlight is the importance of location. So in a lot of places in the state, particularly in the Central Valley, channels can't necessarily convey the higher floods. There might not actually be a good way of achieving ecological functions of flooding in the current system. And we see FloodMAR as an opportunity to help reintroduce some of the functions of flooding, especially if it's done within the historical floodplain. So things like levee setbacks and floodplain restoration can help restore flood functions while also providing recharge. Floodwaters that are redirected to floodplains can provide habitat access, food production like aquatic vegetation, invertebrates, and then also help maintain vegetation in the riparian zone in addition to recharge. So recharge and sort of flooding efforts that are in places that are still connected to the river is really the best way of getting multi-benefit recharge. And I think where those opportunities are possible, they're really exciting from like an ecological and a water supply perspective. So we're really excited about the potential of FloodMAR. We've been thinking actively as a group about ways to better integrate ecological functions into the ways that we're thinking about FloodMAR. We are currently working on a short blog post as a team to talk through some of the ways that we see CEFF potentially supporting and informing the ways that we are thinking about FloodMAR as a state right now. And we'd also really love to hear from this group. We're excited to have this opportunity to engage, and we'd be interested in your thoughts on the value of CEFF or functional flows guidance for how to represent ecological water needs within FloodMAR, or if there are any potential ideas of case studies where we could think about how CEFF could be used together with FloodMAR to help build better and more resilient systems. We'd be really excited about that. So yeah, that is what we had for you today, and I think we are excited to take questions.
Great, thank you, Sarah and Bronwen. Wonderful presentations. There's a few items in the chat right now, but I also encourage people to raise your hand using the raise hand function. Sometimes it's better just to talk it out, but there's a couple like question and answer that was already done on the chat. Maybe we can read that later, but maybe I'll read one from Kamiar. Is there a plan for CEFF to consider how climate change and extreme events will alter stream hydrographs, the magnitude and frequency of peak flows and flood recurrence periods?
Yeah, I'll go ahead and take that question. Yeah, absolutely. So the flexibility of the CEFF framework, the framework itself, definitely allows for this to happen. So there's, we haven't yet done the full work of using the climate models that are out there to look at how natural functional flows would shift under climate change, but that's something we've been talking about for 2 years and would love to partner on and find funding to do. And the nice thing about CEFF as a framework is that adaptive management is inherently part of section C, that third section that I highlighted. And so with the intent that you absolutely would need to be adaptively managing and changing as climate conditions change. So super great question, and hopefully something we can continue to explore and have more data on in the upcoming next year or two.
Great. And as folks continue to put in the chat, also, please feel free to raise your hand. and ask in person. This one is from Dave Bullitt. Is there a plan to apply this in a watershed and evaluate the operations and results?
Maybe Chris, do you want to talk about some of the case studies that we've been doing case studies around the state and several in Southern California?
Yeah, so in Southern California, we've done 2 case studies. One was in South Orange County through their water quality improvement plan. And the question there was, how do we determine where flows are altered, where altered flows may be providing a benefit to the environment, and where augmented dry season flows may be diverted and recycled and reused for other uses. And so we went through the framework. That was one of the first applications of CEFF. So we went through the steps of CEFF to try to identify kind of the flow needs and prioritize where flow management diversions could occur that would be beneficial to the environment and in terms of water supply. And then another example was in the LA River watershed. The questions there were around changes in wastewater discharges, treated wastewater that is currently discharged into the LA River. And so we use the framework in a slightly different way because in this watershed, the channel is highly altered. It's a huge flood control channel and there's some natural reaches. And so we stepped through section A, which thought about the natural flows, but then also thinking about this highly altered urban system. How can we adjust these flows to account for changes in wastewater discharge, changes in dry season discharges, and changes in stormwater capture and diversion. And so those are a couple in Southern California. And then I know Sarah and our partners at CDFW have also used the framework across the state as well.
Great. Mike, you have your hand up.
Yeah, hi everybody. Thanks for the presentation. I have to admit I was on my phone and then in the car and then at my desk, so I may have missed something. But I'm curious if we think about infiltration as having an ecological benefit, and if vertical flow is one of the things that are part of the way you're thinking, like either rising groundwater or infiltration from the channel. I'm trying to think about how the role that FloodMAR is playing, which is like moving surface water to subsurface water, has an ecological benefit in that vertical transformation rather than kind of the horizontal one. And I'm curious if that resonates with you at all.
Recharge achievements.
Bronwen, do you want to take that one?
You're on mute, Bronwen.
Oh, yeah.
Start. I think sorry. So if you're talking about sort of like vertically recharging some of the groundwater, like even some of the shallow aquifers along streams, I think we'd be most interested in thinking about from like an aquatic ecology perspective, like the movement of some of that, the ability of some of that water to have some return flow back to the channel. So it's helping support base flow longer into the season and times maybe it otherwise would have gone dry. I think certainly the goal of just like helping maintain or improve the health of our groundwater supply and keep those aquifers at a level that is more consistent with like historical levels, that is more fully recharged, would have benefits for aquatic ecosystems. But I don't know about just like pure vertical movement in itself. I don't know if that answers it all.
Yeah, I was a little outside the box and waxing philosophical, I suppose. But, you know, like, because I know you're talking about aquatic habitats, and I don't know whether that includes or doesn't include riparian habitats that are like dependent on the stream and dependent on seasonal inundation and things like that.
Definitely, yeah. So I think there's the groundwater levels surrounding a stream, or even just in general, I guess, will be really important for all of the groundwater dependent ecosystems that we are interested in as a state. So riparian zones, wetlands, streams, and managing that's, I guess, the vertical flow back into groundwater basins and helping maintain them over time will help support all of the vegetation and sort of flow that we're interested in. So yes, I think, yeah.
Great. I'm going to get to Graham in a second, but I just wanted to call out a chat that might be a clarifying question. This is from Aaron Fukuda. He says, what are the metrics that measure the success of CEFF? Is it the establishment of specific habitat components, or is it species health? As I also see the work, it is saying that ongoing recharge outside of the floodplain is taking away from the functional flows, so would not be allowed or should be incorporated into the flows. So they are in addition to the functional flows. So maybe just kind of a clarifying of how you see this interacting with recharge diversions.
Yeah, it's a great question, and I'll take a crack at it, but please, others on the technical team, feel free to weigh in as well. So with regard to metrics of success, we would be looking at the functions holistically. So in the CEFF technical document, we actually go into quite detail about all of the different types of ecological functions that we would be looking to achieve with those functional flow components. And you could put a metric of success on every single one of those to know that, yes, you are not achieving it. And that would very much be part of the monitoring and adaptive management process that we highlight and want to include to know and be confident that these flow regimes that we're putting down are doing what we intend them to do. So that's kind of in response to the first one. And then in response to the second one, I think kind of going back to the way that Bronwen presented it, is that groundwater recharge ecologically is very beneficial if it's contributing to groundwater dependent ecosystems, the riparian ecosystem, and the aquatic channel. So if you can make a connection, and if there's a way to show that where you're doing the recharge is then directly benefiting those aquatic surface water, visual surface water systems that are regulated, that we need to account for, that we have to take into account with our environmental flow regimes, then I think that becomes a benefit and a function that you can add in. If you're diverting way out of channel, miles and miles away to somewhere where you can't, it becomes more difficult to see that connection to the system where you pulled the water out of, it becomes potentially more of an issue where you might have to, in a regulatory setting, justify taking that water away from one purpose to serve another purpose, and that becomes a trade-off. That becomes a trade-off that gets evaluated in section C of CEFF that you might need to analyze. So really the multi-benefit comes when you can do this recharge in an area where you know it's really connecting to that coupled aquatic and riparian ecosystem that it's adjacent to. So hopefully that answers your question. I don't know if others want to add to that from the tech team.
Yeah, I think that was a great answer. And I think I would say that we're envisioning that in many cases, you would be able to do recharge in a way that isn't taking away from the functional flows. Like the functional flows are very explicitly not the full unimpaired hydrograph. They're sort of keying in on these pieces of the hydrograph that we know are really important for sustaining river health over time. So we're like under the functional flows approach, you would seek to find places where you can perform recharge, even if maybe it is in a place. Maybe you don't have a good floodplain option. Maybe you are doing it far away. In those cases in particular, where it's not connected to the river directly, it's really important that you maintain the functional flows. And then maybe you can also use some of the water that's in addition to the functional flows to do recharge and seek some of these additional benefits that we want from our water systems.
There's a question. What you're saying is that groundwater recharge that is not riparian beneficial should not be allowed. So I don't think that's exactly what's saying. Maybe Bronwen, or I forget who has it. If you could pull up that slide again, where it shows where the functional flows are versus, the natural flow regime, and kind of what would be available for recharge versus it's the one where you have, the red line. You could pull that one up. So just kind of jumping in here, I don't think that's what they're saying. They're trying to identify, and please correct me if I'm wrong, the kind of the variability that is necessary in a given river. And then yes, if you could explain that, Bronwen, that'd be great with that question in mind.
Yeah, so this is the slide that Sarah walked through early in the talk, and it's sort of just trying to really contrast the natural flow regime with the functional flow regime. So in this example system, that blue line might be what a natural flow regime would look like if people were just not even there at all and we weren't altering the system. We are altering almost all of the systems. We like to drink water and grow plants and have cities. So the red line is a way of thinking about how we can maybe use some of that water while still maintaining ecological function. So it's highlighting these 5 key points of the hydrograph where we know that maintaining water at certain magnitude, duration, and frequency is really important for maintaining ecosystems over time, but it's not the full range. So in this example hydrograph, the red line might be what is decided is the functional flow regime, that water that's really, really critical for our ecosystems. And the gap between the blue and the red would be water that would be available for other uses that is not as critical for the ecosystem. And I think when we were talking about the riparian zone, we were trying to highlight that if you're doing recharge in the riparian zone, you're not even making a trade-off. Like, that water is performing its ecological function, and we're also getting this human benefit of recharge at the same time, like where there's no trade-off involved. So in those cases, we'd be less concerned about whether you're maintaining the functional flow, because you're maintaining that function by the way that you're doing recharge. If you're doing recharge somewhere else that's not connected to the river, then that's when we feel it's a lot more important to think about the functions and make sure you're maintaining functional flows so that you're not really harming the aquatic ecosystem. And that's where it's sort of more important to think about both to make sure that you're actually getting the benefits that you're hoping for.
Great, thank you. Okay.
I was just gonna say, if I might just add exactly onto Bronwen's great explanation there, that we see functional flows as being a balanced approach. There are inherently going to be trade-offs when you have to think about where should we abstract water out of the system for the things that we need versus what trying to maintain an ecologically functional ecosystem with all the ecosystem benefits that we also get from those. And so this graph is trying to highlight that this approach does allow for abstraction, some water abstraction out of the system, and it's a decision of where would you like to put that water and where do you want to store that water? Is that water being stored behind a dam? Is it being diverted off into a field? Is it being stored in the ground? And again, a 10-year flood really is being the maximum flood we're looking to try to retain. We know, like, this year, a lot of the flows in the southern San Joaquin were 50-year floods. Like, there are going to be years where we have more water than we can know what to do with. So we don't expect and would certainly not imply that any flooding for recharge is in any way against the functional flow approach at all. Rather, we see them being complementary. So just to clarify that question. I think Graham's had his hand up for a while too.
Yeah, Graham, please take it away.
Oh, okay. Yeah, I'd like to suggest a research need, and it's not because I want research money, because I'm emeritus now, but it's something I'd like to point out. In LunchMAR, we talk about floodplain flooding as one of the mechanisms, but I think a lot of people assume that you don't get much recharge from floodplain flooding because it's on a floodplain, it's fine-grained materials. My hunch is, however, that the recharge you get from floodplain inundation, especially if you can inundate it long enough, is much more than people think. But there are precious few estimates or measurements of floodplain recharge. One of the reasons for that is it's a regional phenomena. You would need to be able to monitor and do the surface water and groundwater budget on enough of a watershed scale to build more information on really what benefit do we get for groundwater recharge when we inundate a floodplain. So that's a need for research that I think wouldn't be that hard to fill, but it just hasn't received a lot of attention. That's it. Someone can get some money for research.
Any comments from the CEFF team on that?
No, I agree, Graham, and I am eager to see the continued research that's been going on in the Cosumnes River that Helen Dalka and Laura Foglio's group has been doing, because I think it addresses exactly those questions that you're talking about. And again, the idea of the sort of multiple benefits we can get. The state is very supportive of multi-benefit restoration projects. And so it behooves all of us to really think about how can we maximize benefits across the various different actions that we're doing. And, you know, highlighting and showing these, I think, only really helps advance all of us in that direction. So I agree.
Amen.
Great. I think, oh, go ahead, Graham.
That's it.
Great.
Thanks.
I'll take another question, then I'll let Megan say if we have enough time for any others. This one is in the chat from Jesse Roseman. In the rivers where CEFF has been implemented, is there an impact to other water users, such as energy, water supply? And are the impacts different than what would happen under FERC license requirements?
I guess I could take that one. I've done quite a bit of work within the FERC relicensing realm, and we actually see them as, again, complementary. So there are aspects of functional flows that have been implemented in many rivers throughout the state, particularly through the FERC relicensing process. And as we continue to move forward with trying to think about how to maintain ecosystem services and keep our systems resilient, we are hoping to marry or join or think about those requirements and the way that we designate water for the environment in this more holistic functional flows approach. So I think I put in the chat earlier, there's 2 example rivers where both Poudre Creek and Trinity River are probably the 2 examples where we have been for 5 to 10 years now, implementing a more complete holistic approach to thinking about environmental flows. And there's several rivers throughout the Sierra Nevada where we have moved beyond minimum in-stream flows and are starting to institute more seasonal variability in our flows, and which is on its way towards what we're advocating for our functional flows approach. So hopefully that answers that question. I also see a couple questions in the chat, and I think if we have time, it might be good to talk about this difference between very wet years and average or below normal years. And so there's 2 comments that I saw in the chat regarding that CEFF and functional flows is somehow in conflict with FloodMAR. We actually strongly disagree. We think that there are benefits to doing flooding, and if FloodMAR is done in a way where you're spatially conscious about where that flooding is happening, that can be a benefit. Also, again, a 10-year flood is not a very large flood. We often get multiple 10-year floods in a year. We often get multiple 10-year floods year after year. And our very wettest years often release many multiple floods that come down. And under a functional flows approach, what we're really advocating for is just to not divert every single flood flow in all years. And in the very wettest years, there's more than enough water. We absolutely should be putting water everywhere we can to get at recharge. This year is an excellent example. There wasn't infrastructure to put the water in all the places that it needed to go. So I might strongly and gently push back and say that we actually think that CEFF and thinking about functionality of flows and recharge are very much compatible. And there's actually benefits to be had both in terms of groundwater recharge and ecological sustainability if we think about these things together. So not every flood needs to be preserved. That's actually what we're saying in functional flows. There's many floods that are taken for consumptive uses throughout, both in terms of recharge and in terms of storage behind reservoirs.
We have 1 more minute, but I'm gonna, Wes has his hand up. If you could just real quickly ask your question, Wes.
Yeah, my question was looking at the hydrographs, the timing of that first flow was sometime around January, and most reservoir operators, most of the time, that's pretty early in the water year to know what water year type you're actually going to get. You know, aside from what we had this year, obviously we knew in January what was coming for the most part, but more often than not, we really don't know. So how does CEFF account for the functional flows, that peak that needs to happen in January when reservoir operators really don't know what water year type it's going to be yet?
Oh, that's such a great question. And I have 2 really good answers for you because we've been looking into this and have good research. So the first one is that it's not that the peak always needs to happen in January. Peaks come in December, they come in January, they come in March. And really, if you think about geomorphic functionality, all of those peaks provide geomorphic functionality, right? So that's just illustrated because that's the the graph that got put into the paper. But the timing of those peaks can actually be quite variable, and that's an advantage to us when we're thinking about trying to manage water. The second is that there's some really interesting work in terms of reservoir operation and research that's going on in regards to how can we use the flood forecast, the Bulletin 120 flow forecast for the water year, in an optimization approach where we can be thinking about implementing an environmental flow regime in real time as those forecasts evolve through the season. And so there's some, I think later this year, there should be a report out sort of highlighting an approach that can be completed below reservoirs, taking those forecasts into account and thinking about managing environmental flows in real time as you move forward. So it's a very good question. It's something that people are actively looking into, and hopefully there should be some more data and research out on that soon to share.
Thank you.
Yeah, thank you.
Great. And so we're 1 minute over time, so I'm going to wrap this up. Please, everyone, give your thanks to Sarah and Bronwen. They're excellent presentations. And I think there's need for more conversation. Looking at the chat, there's a lot going on here. And so I think, I hope this is a ripe area of conversation and discussion amongst all of us in the FloodMAR network. I think we should just, keep the ideas flowing and the concerns and questions. We now all know each other, so I think we can start talking more readily. And so thank you again, Sarah Yarnell, Bronwen, Stanford, and the folks at CDFW for presenting, and hope to talk to you more later.
Thank you.
Thanks, everyone. We'll seek to get the recording posted to the FloodMAR website within a couple of days. Until then, have a great rest of the day.
Thanks for the presentation.